wheels. The other crown is representing the inertia of the wheels and the vehicle, which are at the speed on the ground. So imagine you have one little time to make a different rotational speed, and you cannot realize usually on the secondary shaft because it is linked permanently to the wheels. You can only work on the primary shaft because you can disengage the clutch, so you can modify the rotational speed of this first shaft. Okay, the input shaft. The two wheels are not unitary with the shaft. You can see it's easy to understand from the picture. You can see an empty space between the hub of the gear and the shaft. So imagine this is free to roll, but not mechanically engaged with the shaft. The only mechanically engaged with the shaft is this little rocket here in the middle. The upper part is a ring. You can move right and left. So if you move right, you make a joint between the left gear and the shaft. So you have this one capable to transmit power to the following gear and out to the wheel. In the middle part, this is a neutral position. You have no mechanical torque delivered. To the left, you engage the second shaft. So this is basically the engagement for every single couple of gears. You can also imagine one single gears always need an engagement like this, okay?
Okay.
So this is, pardon?
Is
Was a
that the
question?
sliding mesh?
Yes, this is a mesh.
Okay.
This is a mesh. You can have different kinds or architecture for the mesh, but this is the mesh for gears. So this is a classic representation for a double shaft gearbox with the representation of all the single couples. So the first gear, second, third, fourth, and fifth gear. You see the arrows representing the input and output. So you can also imagining this is the final reduction and entering into the differential, and the two arrows left and right represent the wheels. So no problem for understanding the work of this one. Please note the interesting thing is you have not the need to have always the free gears on the input shaft. You can also use the secondary shaft. The important thing is you don't need to have permanently in contact the two gears, because this is always a single ratio engaged. The reverse gear is represented in this way. So this is, imagine you need to move physically this little gear entering in this added couple, which is directly coupled with the mesh, so engaged to the final shaft. Imagine you have two gears here, so the two shafts are usually counter rotating, and they are for forward direction. If you introduce a third gear, you have the two shafts rotating in the same way, and so you have a reverse direction. Okay? Another kind which is important to know organization for gears is so named in Italian is presa diretta or direct coupling. You have the enter for the power and the exit for the power from the gearbox on the same shaft. So the normal delivery of the power is entering to the secondary shaft and depending from the gear you use, transmitted again to the upper shaft, which is not unitary. This is divided. This is a split shafting is here in the middle. And so you can have a line, a common line between entering and exit. This is used for have the maximum efficiency in the top gear usually, because the fifth gear or the top gear is usually simply moving the mesh here on the left and so engaging directly the enter of the power. So you can realize a unitary shaft to the output. You don't have any other delivery. Obviously, you have a friction anyway between the gears. They are always rotating, but they are free of load. They are unloaded, and so minimum mechanical losses, if possible. This is also used on some motorcycle, and it is easy to identify because you always can see the output sprocket. This is directly in line with the clutch. This is not back to the clutch, which is the first kind of two shaft organization. If you have this kind of direct line, like maybe Harley Davidson, they use this kind of gearbox. Okay?
Yes.
Okay. There is some interesting, I don't know how much this is interesting for you to go deeper inside of the synchronizer. This is a sample for a mesh with a synchronizer. So this is the complex organization for this. I am interested more to this ring, this grooved ring, which is used to move left and right the mesh, the engagement for the gear. Here on the top end, so right and left are the two opposite gears, the two speed, which this center mesh is capable to engage. Okay, you can see this is sliding left and right over this center hub. The function of the additional rings is making something like a friction. So if you push in one direction, maybe on the left, this center ring, you must push these conical surfaces one into the other, and only when they are capable to reduce or adapt the speed of the shaft, you can have the alignment between the splines and this tooth all round, and so the center ring can move and find the, you can see also this little tooth all round on the gears.
Yes.
Okay. So finally, you can move and engage and make a solid joint between the gear, the annulus, the hub, and this is the shaft passing through this center part. Okay. So this is only a problem of dimensions and correct shape of all the tooth. There are simpler and more complicated architecture for making this, but imagine this is something like putting some very little clutches, making friction between the mesh and the gear. So before you can engage the gear, you must win by mean the clutch, making the same function if you wish to think in this way. They make the same function to start the vehicle from standing. So you have always the engine which is rotating, the wheels are stopped, you use the clutch with friction to make the adaptation between the two different speed. Okay, and so this is like adding little clutches between the mesh, the engagement, and the gears. This is necessary when you have heavy, great inertias. So this is so necessary for cars and especially for trucks. And also the great difference in rotational speed between the following ratios in the gearbox. So if you have in your mind the organization for a motorbike gearbox, you know you have a primary reduction from the crankshaft to the clutch, and so the input shaft to the gearbox. In reason to 1/4 usually of the rotational speed of the engine. So imagine the high revving for a motorcycle maybe is 8,000 RPM. The primary shaft is rotating at 2,000 only, which is a very low speed. So you have very little difference in rotational speed between the primary and secondary shaft. And you have no need really for synchromesh. And also another benefit is the very low inertia of the motorbike. So maybe a very little jump changing gears are well absorbed by the elasticity of the final chain, and the vehicle is easy to accelerate for this very little time changing speed. Okay. If you have not this kind of mechanical help, you need to make in two different time the maneuver to change gears. So the first one is disengage from maybe the right gear. So you depress clutch, disengage, and you have this one not coupled right or left, is neutral. Release the clutch, give a dab on your accelerator, changing the speed of the primary gear so you can adapt to the speed of the following gears you won't engage, and you move again, depressing the clutch, and finally you release the clutch. So this is a double clutch movement and a dab of accelerator inside if you are downshift. If you are up shifting, simply you wait. So clutch, neutral, wait a little moment, clutch, upper gear, and release. Have you noticed this kind of sequence in heavy vehicles, or if you had the occasion to drive an old car without a synchronized gearbox?
Yeah, you need to overdrive.
Yeah.
You have to press the accelerator and then the clutch and change, and that's
Yes.
it.
Yes, you can hear also. This is a typical sound. This is
Yes.
like this. Okay. And okay, this is easier to comprehend, or if you have any kind of experience on this kind of thing. This is also a physical satisfaction to make this kind of joke, even if you have no need to make with synchronized gearbox. But this is for funny and crazy driving. Okay, if you are able to identify the correct RPM, there is a transition moment where the gearbox is in neutral condition, not loaded and not unloaded completely. And this is very sensitive to move the gear shift and pass to the following gear without pressing the clutch at all. This is really a great
Yeah, I
training.
tried with the 500, with the non 500.
Yeah. But also, if you don't want make any kind of too much hazard on expensive car, you can work on usually on motorcycles. It's very easy to change gear without using clutch. Had you not tried anyway?
I have tried.
Okay. Anyway, this was only to introduce to you the need for this kind of argument. By the way, in Italian, the name is doppietta for the use of non-synchronized gearbox. Okay, so no interesting things except for all the pictures are demonstrating to you the different stage of the engagement. So starting from the first one, moving, but this is not so interesting to afford in a deep way in this moment. I leave to you the presentation, and so if you have need for more explanation, or you have your personal curiosity or question, you can write to me. Following, we only afford a final overview about the gearbox commands we need to move this kind of mesh. And so we can use mechanical roads or linking. You can see this is not so simple or linear like the traditional longitudinal engine and gearbox in line, because this is a sample for a transverse engine and the gearbox transverse, also the gearbox. But you always have a movement to move in a longitudinal way the selectors, and another one which is used for rotating the selector, because usually you have the, if you remember, the position for the meshes in two shafts. So you need to move 1, 2, or 3, and this is not only move side to side, but also you need to change position for moving the first one the middle one, and the third one. So the need for the H pattern, which is used normally. And the H pattern is delivered to the gearbox by means of two movements. So one is rotational in this way, the other one is moving this other way, okay, in this case. The problem of this one is the vibration transmitted inside of the habitacle. So the evolution for the mechanical link is using flexible cables. They are quite more precise because you have not this great amount of joints and bolts and articulation. This is an intermediate rockers, another rod, another rocker. So all these pivot points and ball joints, they all make free plays, and so you have no great precision. This is easy to organize the position of the lever and the control on the gearbox if you use flexible cables like this. Maybe so. The only problem is wearing the cable, you can have more friction and so problems for the selection. But usually in the modern realization, you have not this kind because you have Teflon liners inside of the external part of the cable. They are lasting more or less like the car. Clutch is our first first device to be used for start the vehicle and also allow the brake between the engine and the wheels, allowing the gear change. You always remember this is a friction device. So the most used clutch on vehicles today is a single plate, is a single friction plate, which is this very thin one indicated by the letter, the number 4 in the picture. The back part here is included in the flywheel of the engine. The external part is fixed with the flywheel, includes the single spring inside. This is a disc spring, a washer spring, which is also used. You see all these radial cuts. This is also used pushing in the center with your pedal. This is used like a lever because it is hinged. You have a fulcrum here in this position, in this middle crown. So the pressing end of the spring is pulled out. You relieve the pressure over this pressure disc, which is squeezing the friction disc, the clutch disc here in between this external part and the flywheel. So it's a very easy to understand mechanism, except for complication due to the introduction of these torsional dampers and added devices for functionality of the system. But anyway, the concept is very easy. This is another representation, is more easy to understand. So this little center part is joined to the enter shaft of the gearbox of the transmission. Here on the left is the flywheel. So the engine is this way on the left. The external part is simply the starter gear. Okay. If you have heard any kind of names, this is the clutch bell house. in the gearbox. So this is only the external case. This thing part is the disc. This external part is the pressure ring, which is pressed by this part of the spring. You remember this circular spring? This is a washer. Okay. Can you see this empty part means this is representing a cut, one of these radial cuts. Okay. And this center part is representing the fulcrum. So when you apply pressure on your clutch pedal, you are moving this thrust bearing, which is moving this way, this center part of the spring, reversing in this position. So you can have a displacement, or better, you have no pressure between the two parts, left to right, of the disc. Okay.
Yes.
Final reduction, we only have a representation for a differential in the classic traditional mechanic of a front engine and rear wheel traction. So the front part is this way. And finally, we can also spend some words about the automatic transmission. Automatic transmission are responsible for the great diffusion of automobiles, especially in the USA. So solving the problem for the ability of the driver to change gears, and also saving from mechanical hazards and braking for wrong maneuvers and mistakes. Okay, so automatic transmission helps both the comfort and also relief from to be really skilled drivers. Okay. They use both in traditional way this kind of organization. So they use epicycloid gear trains. You know, they are an organization of a central gear, peripheral rolling gears, and an external crown with inner tooth. So you know you can have different speed on the output speed, simply braking or braking in terms of stopping the rotation of this external part or the internal part. You can realize the movement of different gears. So usually you have not less than 2 epicycloid gear trains. The exit from one is used for moving the second one, but you can also go directly on the center part of the second speed and realize the different speed. What is the benefit of this organization? You don't need the mesh in the traditional way, but you can simply make clutches, so friction, to the external part of the crown or the other device. Anyway, you have clutches in between these single rotational parts of the gear. And so you don't need any kind of absorbing rotational speed and engage gears physically, because the gears are always in contact all the time. And please note, anyway, you use some friction to realize the different speed between one gear and another gear. Simply the transition between the two, release one and break the other one, is automatically actuated. If you want to realize really an automatic transmission, you make also an automatic clutch. There are several kind of automatic clutch. Usually you have an hydraulic coupling between the engine and the gearbox in automatic transmissions, but you can also have electromagnetic engagement or robotized engagement. Today, in automatic transmission, we also include robotized transmissions. So they don't use more epicycloid gear trains. They are also responsible for some losses of power, because there are a lot of gears engaged and bearings and other items. So if you use traditional gears like the manual layouts, but simply you move the engagement, the meshes, by means of solenoids and other computerized means. So you can realize today, anyway, robotized transmission with also you can have the option to a manual selection for them. Always the clutch is automatically engaged and managed, but is basically the same traditional clutch for a manual transmission. The only final family of transmission is the CVT. This is so common used in scooters today. So I mean, a lot of you use daily a kind of transmission like this if you have an automatic scooter.
No, I don't.
Okay. By the way, William is arrived or is survived at the bicycle?
Yeah, he arrived right away.
Okay. You are safe?
Yeah, I'm safe.
Fantastic. So, usually, okay, I must confess to you, I had a kind of prejudice to the automatic transmission, especially on motorcycles. I had my opinion, this is not true. Motorbikers which use an automatic transmission. But I must admit, in the traffic, an automatic scooter is really comfortable and amazing, because this is only a great fatigue to work continuously with clutch and shifting gears when you are not riding freely on open roads. But anyway, the principle is two different diameters, minimum and maximum diameter for two opposite pulleys. So variable diameter pulleys. The total length of the belt transmitting the power between the input pulley and the output pulley is obviously always the same length. The difference is actuated by distancing the two halves of the pulley, and correspondingly you have the opposite movement for the other pulley. This is similar. You have in your mind your bicycle. Usually you have the rear pinions. They are disposed like a cone. So you have different steps reducing the diameter from the greater, which is used for lower speed or climbing. And this is the first gear. And so the little sprocket is corresponding to the top gear or the maximum, the faster ratio you have. And similarly on mountain bike, especially, you have opposed disposition for the crowns. So you have an external greater crown and internal reduced crowns. And the combination between them gives to you an extended range of variation in the effort and speed realizable. The same thing is in this one. So if you have the moving pulley opened, you have the belt down in the groove, and so in a reduced diameter. The opposite is closed, so the belt is over the external diameter, and you have the starting condition, so the first gear, or if you prefer, if you are on a slope, great effort, this is the automatically disposition. Increasing the speed, you have centrifugal forces closing the primary pulley, and the reaction for the secondary pulley is forced to open. And so this is the final disposition at the top speed. Okay. Or you have all the intermediate possibility without any step in transition. Basically, you have the side part, because the the cross section of this belt is a trapezoidal shape. You have not the upper or inner part working, but are the side part working here to the side part, conical part of the pulley, by transmitting by friction. The only problem is the friction is needed, so usually they are dry devices, and the problem remains for waste the worms, the heating from the friction. Anyway, you have a great amount of power loss in friction. This is acceptable if you have a very light vehicle and very little amount of power, because we are speaking in terms of percentage of power. Obviously, this is not so good if you have great power, because you have also a lot of power wasted in heating in the same percentage. And the problem is also the resistance of the belt. So overcoming this problem in automotive application, you have this kind of first variation in the concept of the belt inside. You have this multi-layer tape, one left, one right, making some like a rail, simply a rail for all the length of the belt, but they are not working to transmit power. Simply they realize the track for the movement of a family of plates like this. You can see the screen.
Yes.
Okay, you have all these little plates with this particular shape. And so imagine they are working, one is pushing the forward one, and all they are pushing in front of them. So it is a strange kind of transmission because not a traction force like the traditional belt. So imagine this is the rotational way of the transmission. You see the arrows. In the normal transmission, imagine this is the unloaded part of the belt, and this is traction engaged part of the belt. In this kind of belt, you have a compression in this part working to deliver a push force to the upper pulley to the lower pulley, and this is relaxed, is not used for transmit force in normal condition. Okay, so they are sliding all the time on the tape. This is also a relative movement between the plates and the tapes, the metal tapes. But you can realize all this device in steel and special steel, and also have oil into the device to realize lubrication and heat dissipation. The same purpose is realized by this kind of mechanical belt, which is really another kind of multiplate, is more similar to a chain, if you want. So you have a lot of pins engaging in a number of plates. All these plates are used for engaging, but engaging in the grooved, radial grooved part of the pulley. So all of them are evolution of the basic concept of having a continuous variable transmission. Okay. You can also manage the variation in the ratio in electronical way. This is useful, especially if you have a car or a powerful engine. So this is not simply automatically based on centrifugal forces and rotational speed, but it is also possible to select the proper ratio of transmission from input on the electronic devices on the car. Okay.
But will it slip a lot if the torque is too big?
Yes, more or less, this is not so efficient like gears. Anyway, you have more losses in power.
Okay, thank you.
Simply realize also the great number of elements which make the chain and the transmission. So you add all single movements between all the parts and pins, and also the along the life of the chain and pulleys. You must also consider different wearing and elongation in a single part. In this way, is affecting the total efficiency of the system. So very great improvement are made on this kind of transmission today, but they find their application not on very powerful cars. And if you appreciate more the absence of step between every single gear, if you also try or you had a ride on Honda Civic or other cars using this kind of transmission, or Subaru also, I mean, they are using this kind of transmission now. They are very smooth, but not capable of great dynamic drive or sensation. Okay. So, I mean, a little break is necessary for me to fulfill the register with you are present. So basically the register is here. Okay, so starting from Sanjay, please answer if you are present.